Hello, welcome to the presentation of my algorithms course homework 2. In this homework, I solved problems related to the asymptotic analysis. I solved 2 problems for basic level, 2 problems for medium level, and 1 problem for hard level. So now let's get started. So on the first problem, it gave me a function and it asked me to find the big O notation that best describes the time complexity of this function. So let's examine this function. So this function takes an array as a parameter and then it iterates through the array. As you can see here, it calculates the size of the array with this length function. Let's say the size of the array is n. So it will, this for loop iterate through the array for n times, then will print out hello world for each time. So if the n is 4, it will print out hello world to the screen 4 times. If the n is 6, it will print out hello world 6 times. If the n is 10, it will print out 10 times to the screen. So it goes proportional to the size of the array. So the time complexity in big O notation of this function is On. As you can see, I expressed my approach to ChatGPT here. Then I asked for another basic level question for asymptotic analysis. So it gave me another function and it asked for the best big O notation that describes the time complexity of this function again. So let's examine this function. So this function called print pairs, it takes an array as parameter and it has a nested for loops here. So let's assume that the size of the array is n. So this for loop, the outer loop, iterates through the array for n times. And this loop iterates through the array for n times, and they are printing out, they print ij. So the time complexity of this one is n, and n for this one also. So since they are nested loops, the total time complexity is n squared. So it is O(n) squared in big O notation. So as you can see, I expressed my approach. Then I asked for a medium practice question on asymptotic analysis. So it gave me another function and asked for the time complexity. So let's go line by line here. So in the first line, it assigns the first element of the array to the max element variable. Since it's an assignment operation, we are just only working with one element. So one operation occurs here. So the time complexity of this line is 1. And then we have a for loop here. So this for loop iterates through the array. Let's say the size of the array is n. So it will iterate through the array for n times. So the time complexity of this for loop is n. And we have an if statement here. It checks whether the element is greater than max element or not. If it is, it assigns the element to the max element variable. So the time complexity of this if statement is 1. Why? Because it just checks for one element. So there is only one operation going here. So the time complexity is 1. And there is another assignment operation which assigns element to the max element. So since we are just assigning one element to another variable, the time complexity is again 1. And in the last line, it returns max element. So since we are returning only one element, the time complexity is 1 again here. So the total time complexity is 1, 1, 1, 1, and On. Since we are working on worst case and big O notation, the total time complexity is On here. So I expressed my approach here, as you can see, and then I asked for another medium practice question on asymptotic analysis. So it gives me another function. Now let's go line by line here. So in the first line, it creates a set which has the name of C. So we are just creating an object here. So and this object is empty. So the time complexity is 1 here. So we are just doing one operation, just creating an object. So time complexity is 1. Then we have a for loop here. Let's assume the size of the array is n. So for each element in the array, it does these operations. So the time complexity of this for loop is n, since it iterates through the array. And then we have an if statement. It checks whether the element is in C or not. So the time complexity is 1 here, because we are just only checking for one element, not for a group of elements. So the time complexity is 1. And if it is true, it returns true here. Since it's a return statement, we're just only returning true to the screen, into the program. So the time complexity is again 1 here. And in this line, it adds the element to the scene set object. So the time complexity is again 1 here. Why? Because we are just adding one element to an object. We're not working with group of elements, so there is only one operation needed for this line. So the time complexity is 1 here. And then in the last line, it returns false, which is again a return statement, and the time complexity is 1. And overall, the time complexity in worst case, in big O notation, is On again here. As you can see, I described my approach to ChatGPT. And for the last question, I asked for a hard practice question. So let's examine this function. This function is basically a Fibonacci, which is a recursive function. It takes an input value of n, and it checks whether the n number is smaller than 0 or not. If it is, it returns 0. So the time complexity is O1 here. In elif statement, it checks whether the n is 1 or not. So the time complexity is again 1 here. And in the else statement, we have a recursive call here. So I calculated the time complexity in big O notation as O2 over n here. So now let me explain how I did this. So as you can see, I showed my solution to ChatGPT. So let's see this picture. So in this picture, I made a recursion tree here, as you can see. So the time complexity of the function, let's say it is Tn, equals to the time complexity of the first recursive call, as you can see here, and the second recursive call, and a constant k number. This is not important, So the Tn, but before that, let me just explain this tree. So we have a number of n here. So if it's not equal to 1 or smaller than 0, it will call itself with these two functions. You can just think of these expressions as function calls. So it will call for n-1 and it will call for n-2. And it checks whether these are smaller than 0 or 1 checks for the base cases. And if they are not, the function calls itself again with n-2, n-3, n-3, n-4. And in the next step, it calls again n-3, n-4, n-4, n-5, blah, blah, blah. So if we say the number of operations here is C, which is actually 2, but let's say it's C for better understanding. So in the next step, if it's c, it is 2 over 1 times c, because we have 4 operations here and we have 2 operations, which is 2 times c. We can say it is 2 over 1. And the next step, we have 8 operations. We can say that it is 2 over 2 times c. So in the next step, this recursive call will call itself again twice. So 2 will come from here, 2 new calls will come from here, 2 new calls from call from here. So the 2 new calls come from for each of these recursive calls. So we have 8 recursive calls here, so it will become 16 recursive calls in the next step totally. So we can say that it is 2 over 3 times c, which is 16. So the whole process goes on like this. So it will come back to here. The Tn, which is the upper bound, should be this. So we have c here, 2 over 1 times c plus 2 over 2 times c. We are just summing them up as the main equation says. We're just summing them up, and then if we take on common parentheses in c, we get this, and the expression in parentheses is actually a geometric series, and we can just summarize them as 2 over n minus 1. So c is a constant, as you can see, it's just 2, and 1 is again a constant. We can just ignore these c and these 2, and we get 2 over n here, and the Tn should be smaller than or equal to 2 over n. Since we are looking for an upper bound in big O notation, the time complexity goes to O2 over n. So that's why I calculated the time complexity of this function as O2 over n. So this is the end of the homework.